Angie here with Angie's Beyond the Lecture. Now, today's video is just going to be a quick walkthrough of a 2-page handout that I put out on Patreon. And it's basically explaining the differences between how we view the definition of the mole and how it helps chemists determine quantities in their chemical formulas when they're trying to carry out chemical reactions. And just a brief review of what micro and macro stand for when I reference these terms in the handout in the video. Micro just means extremely small. So we know that's a prefix for 10 to the negative 6, pretty itty bitty. And those quantities are typically used in a biochemistry lab at some point. And the macro just means larger. So in chemistry, it's something that we could see and work with. For instance, grams, liters, and of course the mole. And I'm keeping the example pretty basic. I set up the unbalanced equation for representing one sodium atom, one chlorine molecule, and we end up with a sodium chloride formula unit. And then we have, for balancing, of course, we need 2 sodium atoms to join one chlorine molecule. We'll get 2 sodium chloride formula units. Now, just to reiterate, at the micro level, we're talking about atoms and molecules, which are very, very tiny. And of course, chemists can't work with atoms at that tiny, tiny level. At least it wouldn't be practical. So we need to scale things up. Now, at an intermediate point, I'm just throwing out the reference to a dozen. So we know 1 dozen is 12 units. And I could likely say 2 dozen sodium atoms combined with 1 dozen chlorine molecules to give 2 dozen sodium chloride formula units. We can use that to scale up things up a bit. It's not going to be enough clearly because these particles are way, way, way too small. But you can use that as a scaling factor. So in essence, what we would have here, if we have 2 dozen sodium atoms, that's 24. If we had 1 dozen, of course, that would be 12 chlorine. And 2 dozen, we would have 24 of those final sodium chloride formula units. And of course, we're representing this 2-1-2 ratio. For every 2 sodium atoms, we have 1 chlorine molecule resulting in 2 sodium chloride formula units. Can't stress that enough. Everything's proportional here. Now, if we want to apply a much larger proportion, that's where we involve, for the macro level, we use the definition of the mole. And I'll give the technical definition here in a little bit, but we use that for a conversion factor. And that conversion factor is 1 mole of any substance has the 6.022 times 10 to the 23 particles. And we could say, and using the same exact equation I've used in the prior 2 examples, we could say 2 moles of sodium atoms, so that's 2 times Avogadro's number, react with 1 mole of chlorine molecules, that's just 1 times Avogadro's number, we'll end up producing 2 moles of sodium chloride formula units, and that would be 2 times Avogadro's number, or Avogadro's number doubled. So this is real world. We can actually use these quantities to carry out reactions in the lab, should we choose to do this. Again, this is a basic example with sodium and chlorine combining to form sodium chloride. And the rest of the page here, the second page, is just reiterating or emphasizing why chemists invented the mole. And it represents, 10 to the 23. That's a very, very large number. It actually comes out to be in the sextillion, 602 sextillion, and that lands between 10 to the 21st power, which is sextillion, and then 10 to the 24th power, which is septillion. We normally don't see these numbers, but that's what this number represents. And we can call this a chemist's dozen, right? I highlighted that below, except of course this number is much larger than a dozen, or what we accept as 12. And below here, yes, the definition of the mole. So I put this in here just to show students, okay, here's the technical definition, but what we need to extract is simply that it's a quantity. 1 mole of any substance we interpret to have Avogadro's number of particles. And we can say that in different units. We can say particles, representative particles, essentially the same thing. We can say atoms, if you have a single element. For an ionic substance, we use formula units. That's why I use formula units with sodium chloride. And then last but not least, we can use for molecular or covalent compounds, we use molecules. So don't be surprised if you see formula units for ionic substances. It, to me, generally means a molecule, a compound. And that is really it for this particular handout. I just wanted to verbally walk you through it, and because it's 2 pages. And again, I think students have a trouble taking that definition and wrapping their heads around what do I need to take from this definition? How do I apply it in my chemistry problems? And that's really it. We just need to keep in mind if they give you a problem with, say, so many particles and you might need to convert to grams, you first need to take your particle number to moles and then convert moles to grams. We know where we can get grams from the periodic table, right? Every element has their own characteristic mass, and it's the average atomic mass of all the isotopes. So that's how generally everything connects, and I hope you found this video helpful. I do have, and I'll link this here in just a moment, I have a chemistry final exam prep. It's the foundations you need to know. It's about an 8 or 9 series video on the basics, maybe first 6 to 8 weeks of general chemistry or high school chemistry or intro to chemistry. It's largely the same. At the end, there's an 80-minute video which comprises 50 questions, and I take you through those one by one, and hopefully you find that helpful. And again, hopefully you have a great day, and thanks for watching.